All right, everybody. We are talking today about Chapter 8, which is Regression Wisdom. I might be a little quiet this time around. I am losing my voice, and I have no clue how well I'm going to get through this. This is a very important chapter as it pulls together Chapters 6 and 7. Now, a big thing when we're dealing with regression is really all about the residuals. You have to make sure that when you're doing your regression analysis, you actually include the display of the residuals because it tells us how reasonable our model was. Like we talked about in class, residuals reveal things that might not be quite so apparent from the original data plot, and that's why we do them. A curved relationship might not quite be visible through the original data, but it definitely becomes more so when we look at the difference between the data and what an actual line would have given us. And also with the residuals, sometimes we can see multiple groups that might have been hidden within the data. And when you do see that there are two different groups, it may be a choice for you to look at those two data sets completely separately and perform two different linear regressions on that data. For example, if I want to look at the relationship of height versus weight of individuals, I might want to look at that relationship with men versus that relationship with women because their body masses are different. So the residuals themselves show us all sorts of different things. Here we have the duration of emperor penguin dives versus their dive heart rate. While it appears generally linear, you might actually say, okay, I do see a bend in this data. If I go and I plot the actual residuals of this data, you can see a definite difference and a definite clear curve in what's being represented. If you see the data here goes very clearly in almost that Nike swoosh shape versus over here, it's almost linear. I know it's strange that we want to look for the straight enough condition after we do the regression. It's all kind of cyclicals. We check the scatter plot to do a regression. We check the residuals to see if that regression model was appropriate because it reveals what we might have missed in checking the conditions. Now, when we look at the residuals, they themselves might not tell us everything that we want. Instead, sometimes what we'll do is whenever we do regressions, we're going to be doing a histogram of the residuals in addition to a plot of the residuals. Here you can see a histogram of the actual calories from sugar content in cereals. Now, our goal for our histogram of the residuals is that it should be nearly normal. But if I look at this, I can see here a nearly normal group in the center and almost two separate groups on either end. That's not quite apparent if I were to look at all of this data at once, but if I separate these residual pieces into the left, center, and right, you can see on the graph here that they form three very distinct groups, where those groups have very strong relationships. The individual modes in the histogram, 1, 2, and 3, are marked with different symbols, and that makes it so that you can see the relationship. Again, if all of these were just random dots, you might not have seen that. Now, the subsets of groups is kind of what we're talking about before. When you look at data, it has to come from the exact same group. The problem with the previous issues, maybe we had adult cereal, we had your typical children's focused cereal, and then you had the crazy kids cereal like Count Chocula or things made majority-wise with marshmallows. So when there is more than one group in a regression model, you have to kind of determine what makes the most sense. Don't just naturally disregard the different groups and don't just automatically shift through them. You have to look at the context and decide what is the most appropriate. So here are three different regression models fitting the calories and sugar content for each of the three different types of cereals. You can see three very different lines for each of them. One of the biggest mistakes that people make in regression models is extrapolation. Extrapolation is kind of like fortune telling. A linear model's purpose is to make a predicted value, but the predicted value is based off of data that we've gathered. we have to be very careful because we cannot automatically assume that the same linear relationship is going to exist outside our range of data. And it's all about your distance from the mean. In particular, how many standard deviations are you away from the mean? And the further away you are, the more hesitant you should be about making that prediction. If you are into completely new X territory, that prediction is called an extrapolation. And typically, it's not even within the data itself, you're looking at the standard deviation of your data. Extrapolation requires the assumption that nothing in your relationship changes as you go beyond your extreme values in X. Sometimes that's okay when we expect a constant linear rate of change, but not everything in life works in a constant linear rate. So be very, very careful because extrapolations can get you into really big trouble. Do not make extrapolations, and even depending upon who you're talking to, who your teacher, who your textbook is, some places say if it's beyond the range of data at all, it's extrapolation. Some say if you're more than 25% outside of the range of the data, you want to be careful. But in all reality, if you go beyond your data points at all, you are extrapolating. Don't pretend to be a psychic. It's dangerous, but it's exceptionally dangerous when you're talking about time. We cannot look into the future. We are completely and totally incapable of that. And anybody that claims otherwise is kidding themselves. We can make educated guesses as to what's going to happen, but you have to be careful with how much weight you put onto that prediction. If you must extrapolate into the future, just be sure that you're aware of what you're doing and you don't, like I said, don't fully believe that this is what's going to happen. And this is the problem that a lot of people get into when they're playing the stock markets, when they're going off of, even when you're trying to do your fantasy football, you're basing predictions on what has occurred in the past. And that's why gambling can be a very dangerous trend. No one predicts the future. You've got to be very careful. And here's a good example. Several years ago, in the year 2000 actually, we had a very strange presidential election. Florida itself had the biggest issue. They had the issue with hanging chads, they had mystery voters, and the way this was looked at was they said, hey, wait a minute, if we plot the data of the distribution of votes, we have this one strange county that clearly does not fit the data. And it's not just even partially, it's a freaking red flag. And people said, hey, what's up? And what you can see here is what that one single dot does to a regression model. If I include that single dot, it pulls my regression line clearly up in favor of Buchanan. Now, that is a representation of an outlier. And I want you to understand that all of the things that we're going to talk from here on out deal with outliers. Outliers can do many things. The biggest thing that they do is they can strongly influence your regression line. They can make something that might not have a clear linear association appear linear, and it can make something that is linear appear very not linear. Any point that stands away from the others can be called an outlier. Anything that stands away from the expected x's, from the expected y's, or from a cluster of data points. Anything strange deserves your attention. And here is just a cute little clip from extrapolation. This is where I had room for it, and I wanted to put it in here. This is why extrapolating based off of time is a bad idea. Okay, yesterday I didn't have any husbands. Today I have one husband. Oh, dear God, next week I'll have 4 dozen. Yeah, that's just stupid. But sometimes stupid is funny. Okay, leverage. No, I'm not talking about the TV show that runs on TNT, but it's kind of the same idea. A linear model itself will have a poor fit, will have a low correlation coefficient, a low R, with large residuals. But it is important to pay attention to points that have large residuals. That point might actually have what's called leverage. If a data point is unusually far from the average of the x values, its x-coordinate is far from the x average, that point is said to have leverage. Now we're talking in the x direction here. This kind of goes back to what Archimedes said way back when. He said, "Give me a place to stand and I will move the earth." It is the whole principle of leverage that plays a huge role in physics. If you get far enough away with a long enough stick, you can move just about anything, and that stick is basically your regression line. So there's leverage and there's influence. Something that has leverage does have influence. But influence is any point that has a potential to change the regression line. If you take it out, does it drastically change your regression line? Not all points with leverage have strong influence, because you're looking at how big of a change does your regression line have. So if we wanted to talk about the relationship between shoe size and IQ, you shouldn't really see much of a relationship. But if I can find one person that's well outside the range of my population, whether that person has a very high IQ or a very low IQ, if we've got a huge shoe size, that person is going to drag the line of regression closer to it. Especially if you look here, if I were to talk about the mean of the data, the mean of my X data would be right about here, and it's the same set of data points for both values. My X value, however, for the single point falls well outside the general cluster of the rest of the data. That means that one point has extremely strong leverage. And that point grabs the line that might not exist, that might have a correlation coefficient of 0, and it pulls it in its direction. So all of these things, outliers, leverage, and influence, all come from unusual points. And we look at those because sometimes when we look at that one unusual point, we can learn more about the situation at hand than the model itself might tell us. Sometimes it's the exception to the rule that really lets us know what's going on. So that means you can't just randomly delete unusual points from the data. Don't just assume that it was a bad point. What you should do if you see an unusual point is to perform your regression analysis twice, once with and once without the point, to try to see, okay, what is the difference? Is there a difference? And try to figure out how it relates to the context at hand. Be very, 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 very careful. Influential points can hide in your residuals, which is why we look at the general scatter plot first. Sometimes a residual plot will help identify an outlier, but sometimes it will mask it. And that's because if you really do have high leverage, that's going to pull the line of regression closer to it, which is going to actually minimize the residual for that specific point. And this is why it is both important to look at the original scatter plot and the residual plot. They reinforce each other. They work hand in hand. The histogram is also very important because the histogram helps identify whether there are underlying groups or whether or not my distribution of the residuals matches what I expect. So we're going to be talking about in class more things such as lurking variables, more on our causation, the fact that we cannot just assume that correlation implies causation. It doesn't. And what happens when we're looking at summary data. We will also be talking about in class how to create these residual plots that we keep talking about, both in the scatter plot sense and in the residual histogram. So we'll be going through all of that the next couple of days in class, but hopefully you were able to get some terms and some general ideas from this video.